Good afternoon. Can you see the screen?
Yes po, Doc.
Yes po, Doc.
Okay, good afternoon. So, in interest of time, I am forgoing the lecture on statistical inference. I will leave that to Dr. Cruz when you reach your second year, the nitty-gritty of biostatistics as far as statistical inference would be concerned. With the kind of studies that you do anyway for preventive medicine, we rarely reach your statistical inference calculations in real. Okay, so in the interest of time, we're adjusting. So this would be the last lecture. Um, you would have your second long exam in biostatistics next Friday. And then our last requirement would be your finals. And if there is a need, there would be removals for people who would not make it. Any questions so far on the schedule? If we will, but you have exam on biochem next week, right? Okay. So we will adhere to the final schedule because usually I give it before finals para hindi sabay with the other finals. But if you have biochem on the 30th, um, I will go with the finals week schedule. All right? So for this afternoon, we will have accuracy of observations and measurements. I've asked for you to look at the video prior and we will just have some clarifications. So what's your understanding of observations and measurements? Right, in the real world, sometimes you would watch a movie, okay, with your family or your significant other. Okay? And then you will tell the story again. More you watch the same movie, but you would have different summary, you would have different points of view on what was the focal point of the story. Okay, in medicine or in any other science or in any other phenomena as well, observations would differ greatly, much more measurements that we have to do in everyday life. Okay? So these are the different sources of our observation. So inter-observer, intra-observer, inter-individual, intra-individual, inter-observer, and your inter-individual variations would mean that among two people, there would be different sets of observation. So for example, I do the observation, I will count for the pulse rate. I said 108. Then I ask someone else to do the pulse rate for me. Answer is 110. So is anyone correct or both would be wrong? Both correct? So that could be attributed to your inter-observer variation. So Remember, in your statistics, you also have your standard deviation. You always have your plus or minus 2. So that is your inter-observer. Intra, on the other hand, would be one person doing two sets of observations. You have done this many times in your science, biology, chemistry experiments. You do it over and over again to validate or to look if it's correct or if it's consistent. So different measurements could mean at even if you do the same test, that could be attributed to your intra individual variations. Of course, your instrument variations would be different instruments producing different results. So different sphygmomanometers would produce different results. Different infrared thermometers would produce different results, etc. And that could be attributed to your instrument variations. Okay. Sources of variations in observations and measurements, clear? Okay. So we proceed. So last time we had a little bit of accuracy and precision, validity, reliability, etc. And we will add on to that. Okay. So accuracy is the ability of an instrument to test to obtain the correct measure on average. Okay, sorry for your classmate pointed out I marked the correct answer, the wrong correct answer. I will edit it after this lecture. Okay. So it's the ability of an instrument to obtain the correct measure on average. So it's accuracy. Precision is the ability of an instrument to provide the same or a very similar result with repeated measurements. So for example, as I've mentioned in the past lecture, if your weighing scale is wrongly calibrated or your BP apparatus is wrongly calibrated, it could still be precise. Always off by 10 kilograms or always off by 10 millimeter mercury, but it is still precise. But it is not accurate. But for an instrument to be accurate, it must be precise and cannot be present without precision. Okay. So this one would be your 2 by 2 table as far as diagnostic trials would be concerned. So your true disease status compared with your test result and your negative test result, indicating if there is disease or there is no disease. So of course, what are the things that we want to know? We want the test to know, tell us if the test, if we have the disease when we have the if we have a positive result when we have a disease, or we have a negative result when we do not have the disease. So example, how would you feel when you are told that you have cancer because you have a positive test result, but you do not actually have the disease? Okay, so you do not want that scenario. So that would be our false positive or false negative. Or on the other hand, your test result will tell you that you do not have HIV when you actually have it. So again, that is not an ideal scenario. So what we aim for is that positive test result that is truly positive and a negative result that is truly negative, and that is your true positive and your true negative. Okay? On the other hand, you do not want your false positive and your false negative. Okay? So we come again to two words that you have to know always the definition and how it relates to disease and how it relates to your likelihood of disease. So sensitivity is your true positive rate. Specificity is your true negative rate. I always look at it as it's not sensitivity negative, specificity positive, it's not matching. So if it's N, it would be positive. It is P if it would be true negative. I may be confusing you more, but that's the way I remember it for myself. So sensitivity is your ability of a test to detect a disease when it is present, while your specificity is the ability of a test to indicate non-disease when no disease is present. So for example, you want to know if you have the disease of, or if you have the disease or not, what would you want a test diagnostic to be? Highly sensitive or highly specific? Sasabihin niyo, Doktora, pwede bang both? So there are tests that are highly sensitive or specificity. But if you have to choose, which would you choose? It will tell you if you would really have a disease, or it will tell you that you do not have a disease when you do not have it. Where is it ideal? We will see it in the latter slides. Okay, so formula in the 2 by 2 table, your sensitivity is your true positive over your true positive plus false negative. So, and your specificity is your true negative over your true negative plus false positive. Okay? And then you have your positive predictive value. So this indicates what proportion of the subjects who had a positive test result would actually have the disease. So if a person is positive, what is the probability that he or she has the disease? So PPV is equal to true positive over true positive plus false positive. As to your negative predictive value, this indicates what proportion of the subjects who had a negative test result would be actually free of the disease. So NPV is equals to true negative over true negative plus false negative. Okay. So your PPV depends on your prevalence, which will we see on the latter slides, of the disease in the population tested and the test itself. So in general, it depends more on the specificity of the test, especially if the disease prevalence is low, which we will see in this slide. So prevalence is 1% compared to a 5% disease prevalence. So sensitivity and specificity both at the upper 90s. So this is your positive test. So this is your actually sick, true positive, not sick. So this is your false positive, and this is your total. Okay? So this is your PPV is true positive over true positive plus false positive. Okay? So thereby we get this equation 99 over 594, which is 70% PPV. How prevalence affects these equations? So you have your prevalence. Of course, this would have higher numbers. So true positive over true positive plus false negative is 495 over 970, which would equate to 51%. Okay, so it would um, be more or less directly proportional. If it's more prevalent, your PPV more or less increases. Okay. So what's the relationship of prevalence, sensitivity, and specificity if they are all taken together on the predictive value? So for example, if all of them is at 50%, this is your 2 by 2 table. You construct it. Of course, this is your true positive plus false positive 500. So because it's all 50%. So if you calculate 250, 500, your PPV would be at 50% also. So if you manipulate this, as we will see in the later slides, okay, so for example, your prevalence becomes 20%. Okay? Your sensitivity and your specificity remain at 50%. What then happens to your PPV? As mentioned in your two slides back, when you decrease your prevalence, your PPV more or less is directly proportional. So your PPV decreases at 20% as your prevalence changes. Okay? If we have changes in sensitivity, look at how it affects your 2 by 2 table. So your prevalence is the same at 20% compared to the previous slide. Your specificity is the same at 50%. Your sensitivity becomes 90%. So how does it affect your positive predictive value? So it increases from a 20% to a 31%. This is change in sensitivity. Okay? As to change in specificity, you make it 90%, you remain prevalence as 20%, sensitivity at 50%, your positive predictive value becomes even higher at 56%. So changing your specificity would have more impact than changing your sensitivity. So for example, in a highly prevalent disease, so you have to screen for a lot of people. What do you choose? You choose a diagnostic tool with a high specificity, okay, which we will again elucidate on more later. So accuracy is the proportion of your true results in the population. So your true positive plus true negative over your true positive plus true negative plus false positive plus true negative is the equation for your accuracy. Actually, all of what I've said could be summarized in this slide. So if you could recreate this in your exam or open formula, this is the table, the only table that you would need as far as accuracy of observations are correct. Sabi ko nga kay Doc Cruz, mas mahirap pa na nag-open formula, di ba? Kasi, syempre, pag open formula, hindi na kami magre-recall questions because we ask you to have your formulas with you. Okay? So, here is your true positive over true positive plus false positive is your PPV. Same way, FN, um, false negative over false negative plus true negative is equal to your NPV and the other. So you could derive all your equations from this one. So, okay, next concept. would be your type 1 or your alpha positive error. So error that occurs when data would lead one to conclude that something is true when in reality it is not true. Ito yung mga delusional. Kala mo totoo pero hindi. Okay? So this rate suggests that the test is not specific. So error rate of your false positive is your false positive over false positive plus true negative. Okay? On the other hand, you have your type 2 or your beta or false negative error. It's the error that occurs when data would lead one to conclude that something is false when in reality it is true. So, ito naman yung mga dense. Nasa harap na totoo pero hindi siya naniniwala. Okay? So, this rate suggests that the test is not sensitive. So, your false negative error rate is equal to your false negative over your true positive plus false negative. Okay? So, another would be your positive or your negative likelihood ratio, formula of which would be sensitivity over 1 minus specificity for positive likelihood ratio. And your negative likelihood ratio would be 1 minus sensitivity over specificity. Okay? So, definitions of both. So, the likelihood ratio for a positive result tells you how much the odds of the disease increase when a test is positive. Your negative likelihood ratio would tell you how much the odds of the disease decrease when a test is negative. Of course, in any test, there would still be errors, but you measure it with the positive or negative likelihood ratios. So how will we apply it in clinical practice? So the diagnostic tests that we use. So as I mentioned, if we want to rule out false hypothesis or you rule out your differentials, it must have a high degree of sensitivity and a low type 2 error rate. So what are the examples of your screening tests? These are your pap smear, um, other enzymes, for example, in cardiac, there's your CKMB, etc., etc. As to your confirmatory test used to rule in your true hypothesis or diagnosis. So it must have a high degree of specificity and a low type 1 error rate. If we will continue the cervical screening example, your confirmatory tests would be somewhat like a biopsy because we have to rule in the diagnosis with certainty. So any histopath, that is usually confirmatory test, or any tissue biopsy, that is confirmatory test. So but that is not possible to do for all people, especially when the disease is not present as mentioned by the previous slides. Okay, so that would be our lecture. Any clarifications for this short lecture?
None po, Doc.
Na naman. Ano ang exam nyo next week? Ano ang kasabay ko? Wala.
Psych.
Ako lang.
Psych po.
Psych. Sige, so tinanggal nyo na muna yung mga madadali. O sige. Alright. so that you could have your long exam week at the end of April and then prepare for your finals. Okay? So that's it for the lecture. As far as lectures would be concerned, if I get the exam on Friday, I may be able to compute hopefully over the weekend so that you will know if you have to take the finals or not in preventive medicine. So, exemption grade would be a grade of um, at least a 2.5. Okay, so that would at least be an 80. But it is still optional if you want to make your grades better. You could still opt to take the finals. That's fine with me. But we will not nullify if, for example, you get a lower score on your finals. We will honor the finals exam. Okay. For anyone who missed a long exam, you take the finals. You're required to take the finals even if you have grade greater than 80 because I have to do that to complete your grade 1. Second, it would also serve as a grade for your missed long exam. Okay? Your quizzes here and there, your requirements here and there. For example, I see that you are lacking in some areas. So I look at your quizzes and give you plus points for that. If you are looking for uh, reasons why do I have to take some of the quizzes if it's not included. Okay, if I have to, I will make it a long exam for all of you so that your grades will get higher. All right. Any questions, clarifications as far as ending our the finals coverage? 50% family medicine, 50% biostat. So remember your FAMED concepts back in your first semester. It will help you a lot and increase your grades compared to your biostatistics results. All right? Okay. For official first biostat exam, we have lowered the MPL to 55. We have Dr. Cruz and I discussed that we lower the MPL to 55 so that you would not have too much to recover but still do good on your second long exam. Okay? We may repeat some items on your first exam biostat to make sure to so that we could check how you have learned from your previous exam. Okay? Any questions? So
A
if there's
question po,
yes,
Doc,
Mara,
possible po kaya malaman namin yung grades po ng exams namin from the first LE po?
di ba
After,
nagbigay na ako? I sent an email to every one of you, at least for the first sem. Ang utang ko lang naman sa inyo yung first biostat exam.
okay po, thank you, Doc.
Check your email. Nasa Dalta ba yun? .edu, ms.edu, yung MS email nyo. Okay? Any more questions? If there's none, you may leave this call.